Hi. Welcome to Math Online. In our video called Long Division, we learned how to do division problems that had long multi-digit dividends. The key was to break up a big division problem into a series of smaller and easier divisions. First problem. But these divisors are different numbers, and as you'll see, that's going to affect our digit-by-digit division process. To solve this first problem, we start by asking, how many 2's does it take to make 5 or almost 5? Or you can think of it as, how many 2's will fit into 5? And it's easy to see that the answer is 2. So we put a 2 as the first digit of our answer. Then we multiply 2 times 2, which is 4, and we subtract that 4 from the 5, which leaves us a remainder of 1. Now we move to our next digit and we need to bring down a copy of it to combine with the remainder from the first digit. Then we ask, how many 2's will make 12? That's easy, 6, so we put 6 as the next digit of our answer. 2 times 6 is equal to 12, and 12 minus 12 leaves no remainder. And finally, for our last digit, even though there was no remainder, we can bring a copy down and ask, how many 2's will make 8? And the answer is exactly 4, 4 times 2 is equal to 8, which again leaves no remainder. There, we went digit by digit and broke our problem up into 3 division steps, one for each digit. And we got our answer, 264. Second problem. Now let's solve the next example. And right at the start, you'll see we have a bit of a problem. When we ask, how many 8's does it take to make 5 or almost 5? The answer is none. And that's because the first digit, taken by itself, is less than the divisor. 8 is too big to divide into 5. So what do we do? Well, instead of just trying to divide the first digit all by itself, let's group the first 2 digits together. If we group the 5 and the 2 together, then our first step will to ask, how many 8's will make 52? That's better. 8 will divide into 52 about 6 times. So we'll put a 6 in our answer line, right above the 2. Why does it go there? Because we had to skip the first digit and group it with the 2. If we wanted to, we could have put a 0 above that first digit since the 8 wouldn't divide into it any times, and if that helps you keep track of which answer digit you're on, then that's a good idea, but it's not required. So, 6 times 8 is equal to 48, and then 52 minus 48 gives us a remainder of 4. Now, we only have one digit left to divide, so we bring down a copy of it to combine with the remainder and ask, how many 8's will make 48? We know the answer to that is 6 also. 6 times 8 is 48, which leaves no remainder. There, our answer is 66. Did you notice the difference between these two problems? We wanted to go digit by digit in both problems, but in the second problem, the divisor was bigger than the first digit of the dividend, so we had to start out by going 2 digits at a time in that case. Yes, fewer division steps does sound better, but it's really not. That's because the more digits you group together, the harder that division step will be. I thought it sounded too good to be true. It's kind of like climbing stairs. When you have a lot of small steps, each one is easy to climb. But with only a few big steps, each one can be a challenge of its own. That's why we always try to go just one digit at a time. If you only have to divide into 1 or 2 digits of the dividend at a time, it's much easier because all the answers to those smaller division steps can be found on the multiplication table, which you have memorized. But when we have to go 3 or 4 digits at a time, it's a lot harder to figure out the answer of each step. 2-digit divisors. Okay, but how does that relate to 2-digit divisors? As you'll see, 2-digit divisors force us to take bigger steps. To see what I mean, let's try solving 2 new division problems that have the same dividend as before but 2 new divisors, and both of these are 2-digit divisors. In this first problem, we could start by asking, how many 24's will fit into 5, but since our divisor now has 2 digits, we already know that no 1-digit chunk of the dividend will be big enough for that to divide into. So, because we have a 2-digit divisor, we automatically need to group the first 2 digits and ask, how many 24s will make 52? This is trickier because multiples of 24 are not on our multiplication table. Instead, we have to figure it out by estimating, or good guessing. Because we know that 2 times 25 would be 50, 2 is a really good estimate for the first digit of our answer. 2 times 24 is 48, and then when we subtract 48 from 52, we get a remainder of 4. Okay, so far so good. We've already dealt with the first 2 digits of the dividend, so now we bring down the last digit to join the remainder and ask, how many 24s will make 48? That's easy, it's 2 again because we just saw that 2 times 24 is 48, so that will leave no remainder. So the answer to this first 2-digit divisor problem is 22. Now let's have a look at the next problem. It's also got a 2-digit divisor, so we'll start the same way. We'll start with a 2-digit chunk of our dividend and ask, how many 88s will it take to make 52 or almost 52? See the problem? Even though both are 2 digits, this won't work because 88 is already greater than 52. And that means, we're going to have to take an even bigger chunk of this dividend. We need to group the first 3 digits together. But, that's just like doing the whole problem at once, without breaking it into any steps. Yep, and that's why division problems with big divisors can get difficult. When you have a 2 or 3-digit divisor, each step might be as big as the whole long division problem. And it can take a lot of trial and error to figure out. Estimating. In fact, if we had our way here at Mass, when division problems get that complicated, we just let students use calculators to solve them. What do we want? Calculators. When do we want them? Whenever we have long division with 2 or more digit divisors. Okay, but what if we don't get our way and you need to solve this problem without a calculator? What's the best strategy? Well, a little estimating will help us make much better guesses at our answer. The numbers 88 and 528 are kind of hard to work with, but if we made estimates of those numbers, like if we changed them to 90 and 500, that would make it easier to estimate the answer. Since 100 would divide into 500 exactly 5 times, that means that 90 will divide into 500 at least that many times. So, let's make 5 our first estimate for the answer. To check to see how good that estimate is, we multiply 5 by 88 and then subtract that from 528 to see what the remainder is.